Okay, so the first part here is asking you to determine what function was being transformed and then what happened to it. So let's say for the first one here, for part A, the original function, maybe you could say like y equals x squared. And then if you take that as the original function, here what you're doing is you're multiplying by the 5. And that means that you're vertically stretching, or vertically stretched by 5, or a factor of 5, by a factor of 5. Okay. Going down, so this next one, very similar. The original function, I think, here we can say that it's the cube root function, so y equals cube root of t. And now what we're doing to this one is we're multiplying by 1/7. So we're taking all of the outputs and we're multiplying them by 1/7, which is less than 1. So they're being compressed. So this is a vertical compression by a factor of 7, right? Multiplying all of the outputs by 7 would compress the function down. Okay. Continuing on, so for the next one, I think the original function here, I would say, should just be ln of x. And then what are you doing? You have the 6x here, so you're multiplying the inputs. So to go from here to here, you're multiplying the inputs by 6. Which means that you are compressing the function. And so this would be a horizontal compression by a factor of 6. And then that's one, the original function here would be y equals x squared. And then how do you go from the original back, or to the new one, I should say? Well, you're multiplying the inputs by 1/5, right? The 1/5 is in the parentheses, so you're changing the inputs by that, which means that you are stretching it horizontally by a factor of 5. So the factor wouldn't be 1/2 or 1/5. It would just be 5. Okay, maybe let's do something that's a little bit more involved. So for part G here, the original function I think to take is e to the x. And then if you look at this, there's 3 things happening. One, we're multiplying it by the 3, we're multiplying the inputs by the 1/2 and the exponent, then we're adding 1 on the end. And so we would say that this is multiplying by the 3 is the vertical expansion or the vertical stretch. So it's vertically stretched by a factor of 3. And then that's the first one. Second, you're doing a horizontal scaling because I'm multiplying the inputs by 1/2. And so this is a horizontal. Then here it would be a stretch or expansion. So horizontally stretched by a factor of 2. That's the 1/2 in the exponent. So, and then lastly, I'm doing a vertical shift because I'm adding 1 on the end. So then this is shifted up by 1. So that would be the transformations. Okay, and let's go the other way. So let's take a look at the last couple of questions here. So for question 4, g of x is formed by reflecting f over the y-axis. You scale it vertically by a factor of 5, and you shift it down by 6. And so we're writing the function for g of x, so we should have g of x here. And then you just read off what you're doing, and you have to be careful that you do it in the right order. So over the y-axis, a reflection over the y-axis means that you multiply the outputs by -1, but you're also scaling it by a factor of 5, and that goes in the front. So you're really doing -5 times f of x. The negative is because of the reflection. The 5 is because you're scaling it vertically. And then you're shifting it down by 6. So you would just subtract 6 from the end, and this is your function in terms of f, in terms of what you started with. And then similarly, for the last one, g of x here, what are we doing? We're shifting it right 0.6. We're stretching it horizontally by a factor of 3, compressing it vertically by a factor of 2, and up 14. So these 4 transformations are all going to come in. So compressing it vertically by a factor of 2, that's on the outside. So maybe we can think about doing that first, sort of. So the 1/2 would go there because you are compressing it vertically, you're squishing it, so you have to multiply your inputs by 1/2. And then what's happening on the inside, or to the inputs. So you're shifting it right, which is something to do with the inputs, and then you're stretching it horizontally by a factor of 3. That also has something to do with the inputs. So this would be doing your stretching it vertically by a factor of 3. So you have to multiply the inputs by 1/3. And then this is x minus 0.6. That is the shift right by 0.6. And then you shift it up by 14. And so you add 14 on the end.